Question number 6 says, which of the following is true for projectile motion? This is just a straight memory thing. You're supposed to know that the horizontal component is constant, whereas the vertical component is changing under the influence of gravity. So I pick B there. Question number 7, a ball is thrown vertically upward at 20 meters per second from a height of 30 meters per second above the ground. What is the speed on impact with the ground below? So it helps to draw a diagram of this. Basically, we're looking at something like that, where the distance that it goes up needs to be accounted for, and the fact that it is 30 meters above the ground. So I want to know what VF is. VF squared equals VI squared plus 2AD. One of the great things about this formula is that if you keep your sign straight, all of the math works out on its own. VF squared is equal to 20 squared, the vertical motion, the vertical velocity initially, plus 2 times A. Now this is negative 9.8. And it is negative 30 because it's below. That convention of direction is really helpful, because when you solve this, you will get that VF is equal to 31.4. Of course, we had to square root everything in order to get that number. For question, let me just put that in there for C. All right, for C. For number 8 then, it says an object is launched over level ground at 35 degrees above the horizontal with an initial speed of 52 meters per second. Again, drawings are really useful. 35 degrees. Initial speed of 52 meters per second. Work out our component, Vy. Vy is the opposite. So 52 sine of 35 gives us 30 meters per second for the initial. It wants to know the total flight time. Well, if it's going to be launched and then return to the same level, the final velocity must equal negative 30. This is going to be useful to us because we can then set them equal to each other, because we have the formula V is equal to V naught plus a t. We want to solve for t, so t is equal to V minus V naught all divided by a. I'm going to get then that 30 minus negative 30 divided by our acceleration, 9.8, will give us a time of 6.1 seconds. I pick B. Sound good? All right. Question number 9. Has a 2-kilogram block dropped from the roof of a tall building. At the same time, a 6-kilogram ball is thrown horizontally from the same height. So let's just draw this picture. We have a block that is going to drop, and we have a ball that is thrown horizontally. Now, again, the helpful thing is to remember that the only thing that matters here is the distance y. Since dy is the same in both cases, we can therefore assume that they're going to hit at the same time. The block and the ball hit the ground at the same time because they have the same vertical acceleration. They actually have the same initial velocity in the y direction too. So pick D. Number 10. We have this diagram representing the motion of 4 cars, A, B, C, and D. the greatest acceleration during the time interval of 10 seconds. Acceleration is the change in velocity over the interval, change in time. Another way to think about this is the slope of the velocity versus time graph. A casual look at this one will show us that the steepest slope is d, and therefore it is also the greatest acceleration. Number 11. You might as well keep going here. These ones are quick. Oops, bring that back. And number 11, a ball is rolled off a vertical roof at 16 meters per second. Sorry, horizontal roof at 16 meters per second. How long will it take for the ball to reach a speed of 18 meters per second? This is the picture at the start. Vx equals to 16. In the end, what we need is a total velocity that looks like this, which is 18 meters per second. Well, remember, this Vx remains constant. It is still going to be 16 meters per second later, no matter how much later we look. The difference is, what is this y component? What is the change due to acceleration in the downward direction? And for that, what we need to do is consider the y component only. It's helpful to know what the y component is equal to. So Pythagoras' theorem gives us that 18 squared minus 16 squared, when we square root it, will leave us with the component that we want, 8.24 meters per second. Now all I need to do is figure out how much time is needed to get to that speed. Well, v is equal to v naught plus at. The initial velocity was 0 since it was launched horizontally. So v is equal to at. I want to know, solving for t is equal to the 8.24 meters per second divided by the acceleration due to gravity, 9.81, gives me 0.84 seconds. 0.84 seconds, B. All right.